So in this video, I'm going to be walking through a port scanner script that I wrote in Python. It's a simple script. It's designed to just scan a specific IP address for open ports within a given range. So the script efficiently handles multiple ports using concurrent threading, which lets us do faster execution. So in this walkthrough, I'm just going to go through every function and its role in the script, and then we'll do a quick demonstration of the tool once we're done with the walkthrough. So we start out with a disclaimer. Port scanning can be intrusive and it can cause congestion on a network, so don't do it without permission. It is considered a hostile act by some. Real quick, we define the globals of common ports. These are just port numbers and associated protocols that are going to be fed into the script so that we can identify the port and the protocol when we figure out which numbers are open. So the modules that we are importing, we use socket for network communication and checking port connectivity. We use argparse to parse the command line arguments. The arguments are going to be the IP address and the ports you want to scan. There is a default scanning of ports 1 to 1024. IP address is going to validate our provided IP address. Concurrent futures does multi-threading, so we can scan ports concurrently. Time we're going to use to just measure the duration of our scan, and then sys is going to exit the script in the case of an invalid input. So moving down to our functions, parse input uses argparse. It's going to retrieve user provided values for the target IP address, which is tech I, and then tech P is the ports to scan. Like I said, we do a default of 1 to 1024. So you can specify a single port, a range of ports, or multiple ports. And this is going to call validate ports, which is the next function to process and handle validation for the port input. And then if there's an invalid IP, there's an exit message. So validate ports accepts ports in different formats. Like I said, a single port, like port 80, you can use comma separated ports. You can say 22, 80, 443, or a port range. So it makes sure that the ports fall within a specific range of 0 to 65,536. And then it returns a list of valid ports and raises errors if the input is incorrectly formatted. If you specify a single port, it's going to return it as a list, just because we're going to iterate through that when scanning. So scanning individual ports, basically we use the socket.socket to create a TCP connection. We have a timeout that limits connection attempts to 1 second. And then here with our sock.connect, this is going to attempt to establish a connection, returns 0 if the port is open, returns false if the port is closed, or an error occurs, and then we use the with statement for proper cleanup. So next, the scan ports, plural function. This uses thread pool executors to scan ports concurrently. So basically you submit tasks to scan each port asynchronously. So as completed, what that's going to do is it's going to iterate over finished tasks and retrieve the results dynamically, and then it stores open ports in the open ports list and prints which ones are open. So this is going to make it execute substantially quicker. We're scanning over 1,000 ports at once. I commented it out quite a bit. We basically created a dictionary that maps future objects to ports. So if you're not familiar with concurrent futures or thread pool executor, you can read into that, and there's some detailed documentation here. Display results iterates over the detected ports that we find. It retrieves the associated service from common ports, and will default to unknown service if not found, and then it formats the output neatly using string alignment, which is this. And then our main function records the start time, calls parse input, and scans the relevant ports. So let's move on to a demonstration. So I am on a Kali virtual machine, and I'm going to be scanning a IP address here from Hack the Box. So I just linked it up here, fired it up, connected via Hack the Box is OpenVPN, so should be connected. Cool. All right, so as you can see, we are connected. We have a connection to, we're able to reach this IP address. So first I'm going to run an Nmap scan. Nmap stands for Network Mapper. It's like one of the most well-known network tools out there. Very commonly used in ethical hacking, and it's used to scan ports, among other things, identify services. So I'm doing this just to demonstrate which ports are open on this host, and then we're going to make sure and check against our script and confirm that it works. So you can see on this host it has port 22 and port 80 open for SSH and HTTP. So we're just going to see that our script shows us the same. So first we're just going to demonstrate it without specifying any specific ports, and then we'll go through all the different iterations of optionality to confirm that every specification works. So when we scan the IP address, I'm going to make sure it matches. I already did this. Cool. So without specifying the ports to scan, it's going to scan ports 1 through 1024, and it works. Our open ports come up, they match what Nmap determines. So let's just make sure that it works for all conditions. So if we specify port 22 by itself, it should just show port 22, and it does. And if we specify FTP, which is port 21, it should say not open. Okay, no open ports detected. Great. It looks like our script actually executed faster than Nmap. Nmap is a little stealthier. It doesn't make a full connection. So we basically complete the three-way handshake and return a full socket connection with our port scanner, whereas they do a half complete and then they send an RST packet, which is stealthier. So what other cases can we go over? Let's do a range. Let's call it 20 to 70. We know that 22 and 80 are open, so 22 should just show up. Cool. Let's try multiple. Let's try 30 and 80, so just 80 should show up. Great. Let's try 50, 70, 100. Them should show up. Great. So it looks like the port scanner works. So we just demonstrated how you can scan a single IP address, and the base is going to be ports 1 through 1024. You can scan multiple by using a comma. You can scan a range by using a dash, and you can scan single ports as well. And that functionality all works. So that's the end of this demonstration. This port scanner is located on my GitHub, which is at @IamChrisQuinn. Probably better off just using Nmap, but it's a good demonstration of programming tools and network programming here. Again, do not use this, do not scan a host without its permission. It can be considered a hostile act. So I hope this was helpful. Thanks.